The learning objective for this lesson is to be able to sketch and describe force extension curves of an elastic material and investigate the relationship between force and extension of a spring using some results that I have collated. We will now look at Hooke's law, what is meant by Hooke's law. Hooke's law states that the extension of the spring increases directly proportional to the force applied. So in other words, if I was to double the force acting on the spring, then the extension of the spring should also double. If I was to triple the force acting on the spring, then the extension of the spring should also triple. Not the original length, we're talking about the extension. Hooke's law states that the extension and force are directly proportional. So to carry out the practical investigation for Hooke's law, you will need the following equipments. You'll need a spring, a slotted mass carrier, and that has a mass of around 100 grams without any other mass added on, a 30 centimeter ruler or a meter ruler, a clamp stand, 2 bosses and 2 clamps. And once you have set up the equipment as shown on the diagram, to start the practical, you will firstly hang the spring on the top clamp and measure the original length of the spring. Now the original length should have no masses added onto the spring. Once you have measured the original length, you will then get the empty slotted mass carrier and place it on the spring and measure the new length. And as I said earlier, the slotted mass carrier has a mass of around 100 grams. You will then subtract the new length away from the original length, and that will give you the extension of the spring with approximately 100 grams. And you will keep adding on 100 grams and measuring the new length and calculating the extension every time you add on 100 grams. Okay, as I said earlier, to calculate the extension of the spring, you will need to measure the original length. Once you have the original length, you will add on 100 grams and that will be your new length. To find out extension, you subtract the new length from the original length and the blue arrow tells you the extension. If you now add on 200 grams, again you measure the new length, subtract the original length, and the remainder will be your extension, and you will repeat this until you have added on the amount of mass that you desire. In terms of collecting results for this practical investigation, you will need a results table with 4 columns. The first column is the mass that you will add to the spring. The second column is the force added. Now to calculate the force, you simply multiply the mass by the gravitational field strength, which is around 9.8 newtons per kilogram. The length of the spring, so that's the length every time you add the mass to the spring. And the extension, as we said earlier, is the new length subtracted by the original length. To plot the graph, on the y-axis you will have extension in centimeters, and on the x-axis you will have force in newtons. When you plot the results, you should get a graph as shown at the bottom of the slide, where you get a straight line. And looking at the results, we can see that the extension of the spring increases directly proportional to the force applied, provided we have not gone beyond the limit of proportionality. So if we were to double, for example, if the force is at around 2 newtons, we can see that the extension is around 7 centimeters. If we were to double the force from 2 to 4 newtons, then the extension would double from around 6 to around 12 centimeters. So we can say that doubling the force does in fact double the extension, which is what Hooke's law states, as long as we don't go beyond the limit of proportionality. We will now look at what happens to an elastic material if we go beyond the elastic limit. We said earlier, if a material is within the elastic limit, if we double the force acting on the elastic material, then the extension should also double. They behave directly proportional. However, if we apply force and the material goes beyond the elastic limit and it now enters the plastic region, then the material will stop behaving elastically, it will start to behave plastically. This is where, if you remove the forces stretching the material, the object will no longer return to its original size. It will stay permanently deformed. And if you were to increase the forces acting on the material further, eventually you will reach the breaking point and the object will break into two. And this is where, like for example, a rubber band, if you keep stretching it, it stays deformed, and if you keep increasing the forces further, eventually the rubber band will start to snap and break.